Our mathematical models presentation is on base 10 blocks. The examples given for the CSA sequence will be based off of the first grade math standard 1.NBT2A. Base 10 blocks could be used for students to help students visualize and manipulate numbers, making math easier to understand. Teachers could use base 10 blocks to model concepts, reinforce understanding, and create a fun hands-on learning experience. I've provided an example of base 10 blocks. There's a unit, a rod, a flat, and a cube, which represent ones, tens, hundreds, and thousands. For the examples that I'll be using, we will only be using the unit and the rod for first grade. Resources needed for the lesson will be base 10 blocks. Since we are meeting through Zoom, they will be digital. I have provided a URL where you can access the digital base 10 blocks. Go ahead and click on the link to use the manipulative. I will be going over some vocabulary that I will be using throughout the CSA sequence. The first term is digit, numbers from 0 to 9 that form part of a number. The second term is place value, the value of a digit that is based on its position in a number. The third term is ones, a place in the place value system that has a value of 1. Example is 1, 2, 3, 4, 5, 6, 7, 8, 9, or 0. And the fourth term is tens, a place in the place value system that has a value of 10.
For the concrete section, I will ask you to open up the URL link I provided earlier of the base 10 blocks. When opening the link, it should look like this. Let's begin at looking at this left side. We see flowers. On our visual, we see 12 colorful flowers. These flowers represent countable objects. Now let's look at the digital base 10 blocks. We will now start counting out 12 single unit cubes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now let's go ahead and spread them out. This helps us see that there's 12 units. Now each cube stands for 1 flower and 1 count. Once we have our 12 units, we group 10 of them together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This grouping transforms into a rod. I'm going to go ahead and grab my pen and circle the units. And this rod represents one group of 10. The remaining 2 single units stay as they are. So now we've built 1 rod and 2 units, which represent the number 12. Now let's go ahead and go back to our PowerPoint.
In the semi-concrete section, students will be given a picture, like a group of flowers, and a number that matches how many objects are shown. They'll also receive a place value chart with 2 columns, one for tens and one for ones. Using base 10 drawings, students will show how the number is built. For example, If the picture shows 12 flowers, students will draw one 10 rod in the tens column, because 10 flowers make one group of 10. Draw 2 unit blocks in the ones column for the 2 leftover flowers. This helps students see how the number 12 is made, 1 10 and 2 ones, and understand what each digit means based on where it's placed in the chart. For the abstract section, students will complete a place value worksheet that helps them show their understanding using numbers only, no pictures or drawings. Each problem gives a 2-digit number, and students must break it down into tens and ones by writing the correct digits in the empty boxes. For example, if the number is 12, students will write 1 in the tens box and 2 in the ones box. On the right side, I have provided what a completed worksheet looks like.
I'm going to briefly talk about base 10 blocks and how they can be used in 3rd grade and in 4th grade. So this right here on this slide is a 3rd grade standard, and it's for fluently add and subtract within 1000 using strategies and algorithms based on place value, properties of operation, and or the relationship between addition and subtraction. So from this standard, I'm just going to focus on discussing how we can use base 10 blocks for addition based off of place value perspective. Base 10 blocks help students understand addition by using them as manipulatives. Students are able to break down large numbers into ones, tens, and hundreds. This video right here is a great resource that demonstrates that. We provided the link to our presentation, so when you get the chance, you can check out this video. I highly recommend it.
Now, clicking on this link will take you to this video, which I'm going to go ahead and play it for you. And as well as Natalie mentioned, you can go ahead and watch this video anytime you'd like. We'll provide the URL for you.
Welcome to kidsacademy.mobi.
Hello, my name is Mike, and I'm here today so I can help you add using base 10 blocks. I love base 10 blocks. Building with base 10 blocks is awesome. But you can also use them to help you add and count and make some really hard math problems a lot easier. First, let's review what the base 10 blocks really are. Here we have 1 cube, and 1 cube is just equal to 1. Then we have something we like to call a long. A long has 10 cubes in it. A long usually represents 10. And we usually put longs in the tens place. Remember that for later. Then we have 1 flat. 1 flat has 100 cubes in it. And we know this because we can count each cube until we get to 100, but we can also count using longs. There are 10 longs inside the flat. Just trust me, guys, there's 100 cubes inside the flat. Now, using this information, let's read the directions and start our worksheet. Use the models to add. Not those models, they mean the base 10 models. Circle the correct total on the right. Let's get started. First thing I like to do is make a place value chart. This is going to help me keep track of all the numbers I put together, and then we'll just be able to read the number for the right answer. So first, let's make an O. First, let's make an O for the ones place, a T for the tens place, and an H for the hundreds place. Now, let's count each place separately. First, in the number 341, I know that there's 1. We see 1 cube, just 1, only 1. In the number 25, there are 5 ones, and we can see that because there are 5 cubes. 1, 2, 3, 4, 5. Instead of adding 1 plus 5, let's just count the ones as one group together. So we'll start with the 1, 2, 3, 4, 5, 6. Altogether, there are 6 ones. Let's do the same thing for the tens. Let's just count them as one long each. And let's see how many there are. In the number 341, there are 1, 2, 3, 4 tens. In the number 25, there are 1, 2 tens. Now, just like last time, let's count them all together as a group of 10. Now, just like last time, let's count them all together as groups of tens. 1, 2, 3, 4, 5, 6. There are 6 tens. So let's write 6 in the tens place. Then if we go over to the hundreds place, number 25 has no hundreds. But the number 341 has 1, 2, 3 hundreds. So let's put that in the hundreds place. Now we can just read this beautiful number all together. And if I look at this number, I know the number I'm looking at is 366. And that's choice A. So we can circle choice A. Whoa, whoa, whoa. Let's check our work to make sure 366 is really the correct answer. One way to check our work using place value is to write the value of each place. Here's what I mean. Let's make that handy place value chart again. Start with O for the ones place, T for the tens place, and H for the hundreds place. Now I remember how many ones there are, but let's just count them again to make sure. 1, 2, 3, 4, 5, and 6. There are 6 ones. And I remember 1 cube is equal to just 1. So 6 ones equal to 6. Then again, we're going to count our tens, and I remember, but let's just make sure that there are 1, 2, 3, 4, 5, 6 tens. But since there are 10 cubes in each long, we have to skip count by 10 6 times. So, let's do it. 10, 20, 30, 40, 50, and 60. 6 tens equals 60. And finally, there are 3 hundreds. 1, 2, 3. But there are 100 cubes inside each flat. So we have to skip count by hundreds to figure out how much 3 hundredths equals. I wonder how much 3 hundredths equals. Let's count. 100, 200, 300. So now we're left with these even numbers. And if we write them really clearly, lined up in the right place, look how easy adding these numbers can be. We have a 3 in the hundreds place, with a 0 in the tens and a 0 in the ones for 300. Then we have a 6 in the tens and a 0 in the ones for 60. And finally, we have a 6 in the ones place and nothing else for the number 6. If we add these numbers together, we'll see that 0 plus 0 plus 6 is just 6. Again, 6 plus 0, or 0 plus 6, is 6. And 3 plus nothing is 3. And we have the same number as before, 366. I'm pretty sure our answer is 366. We could check it even one more way if we want to just be safe.
And that was a great example. If you'd like to go ahead and finish watching this video, go ahead and follow the URL link after this lesson. Now let's go ahead and go back to the PowerPoint.
Base 10 blocks can be used in 4th grade as well. Here is my standard. So find whole number quotients and remainders with up to 4-digit dividends and 1-digit divisors using strategies based on place value, the properties of operations, and or relationship between multiplication and division. Illustrate and explain the calculation by using equations, rectangular arrays, and or area models. I provided this link as a demonstration on how to include the base 10 blocks for division. And it's a really great strategy, especially for students who have difficulty with division, because it breaks it down into simple steps.
And I'm going to take you to this last link that we've provided. I'm going to go ahead and play this for you.
Hi. This video is to help with partial quotient division, okay? And what I'm going to do is I'm going to go through the concrete, representational, and abstract sequence, so that for those kids who are not getting this concept, the concrete part might be what they need, okay? But I'm also then going to transfer that onto the paper as representational, and then I'll also show how that relates to the abstract, okay? So here we have a divisor of 3. Now, typically the divisor is the number in each group. But for this particular demonstration, I'm going to flip my thinking a little bit, and I'm going to consider this the number of groups instead. Naturally, it won't matter. I'm going to get the same answer, but just because it's a lot easier to show if I just kind of flip around my thinking a little bit. So I'm just going to create 3 spaces. Okay, 3 spaces there to represent each one of those, so 3, okay? First thing I'm going to do is build that number with base 10 blocks. Okay, this number is 630. So there are 600s, and here is 30. Okay, so I'm going to deal with the hundreds first, okay? So what I'm going to do now is I'm going to go ahead and share out. I'm going to divide the hundreds into these groups until I run out. Okay, 1 in each group until I run out. So there's 1, there's 1, and there's 1. And naturally, nice round number for the purposes of this. And I see here that this one, 200, 200, and 200. Okay, so now I'm going to transfer this idea representationally. I'm going to transfer it here by drawing my 200s. Okay, I'll move those out of the way for now. And what happens up here? What happens up here is that I now know that this value is 200, okay? So now what I can do is say to myself, 3 times 200 is 600. Let's subtract that out, and I have my first partial quotient. Okay, 630 minus 600 is 30, okay? Let's deal with the 10s now. Okay, so here are those 10s, which we hadn't dealt with yet. I'm going to go ahead and share it all out. Okay, I'm going to represent it by drawing it. I know the value of each one of these is 10. Okay, and so what did I do? Okay, well, I have 10 in each group now. 3 times 10 is 30. Subtract that out, get 0. Here's my second partial quotient. Putting them together, 200 plus 10 is 210. Okay. This is one way you can kind of show the kids what the division really is doing, what's happening when you divide. Something to stress would be that we're only thinking about one of the groups when we're looking for our partial quotients. They might want to try and put them back together again. Okay, so really stress that really what we're trying to find out is what number is in each of the 3 groups. Okay, so that's one thing, that's one pitfall that you might run into. Otherwise, I am going to also show you another method that is more representational in nature, and that will be in the next segment. So hope.
And this was also a great 4th grade example on how to use base 10 blocks. Now I'll be taking you back to the PowerPoint to finish off this presentation.
So just a little bit more description about the video from the previous slide. Base 10 blocks gives students a hands-on visual way to see what division looks like. So it helps students who may find division challenging get a better concept of what division is exactly. The division problem in the video was broken down into manageable steps. So if you get the chance, I highly recommend to watch the videos I mentioned in the slides I just talked about. And they are definitely great resources for you to use in your classroom.